Alright guys, so since I won't see you in class today, I did want to go ahead and finish up the review and make sure you got to see the rest of the problems worked out. And if you have any questions after watching this, just email me and I will get back to you as soon as I possibly can. So the next problem that we have to work, we want to find the equation and standard form. Remember that standard form again is where we have the ax plus by is equal to c. So the two equations that we're going to use for this, we're going to need two. The number one is that we're going to need to find the slope. Okay, that's that m equals y2 minus y1 over x2 minus x1. And then the second one we're going to need is called the point slope formula. Now, I use this a little differently than most people because I think it's a little easier to work with. So what I like to use is y equals m times x minus x1 plus y1. And basically the three things that we need is we need the slope, which is our m, and we need an x1 and a y1, which is the point. That's why you get the name slope point formula or point slope formula, is because those are the two pieces of information we need. Well, you can see that we do have a point, but we don't have the slope. That's why we need the first formula. So again, let's go ahead and label our points here. So this is x1, y1, x2, y2. And we're going to use our formula here. So m equals y2, which is going to be negative 12, minus y1, which is going to be a minus a negative 12, over x2, which is negative 11, minus x1, which is 3. Now remember, two negatives make a positive right there. So this is going to be negative 12 plus 12. And on the bottom, we still have negative 11 minus 3. So this is going to be 0 over negative 14. 0 divided by negative 14 is still 0. So we're going to find out that this guy right here is 0. Now, we just need to pick one of the 2 points that we have given here to use for our x1 and our y1. So I'm just going to use the same one right here that we've already labeled x1 and y1. And we're going to put the 3 in for x1. We're going to put the negative 12 in for y1. So we're going to end up getting y equals 0 times x minus 3 plus a negative 12. Okay, so here's the cool thing. Again, we love zeros because if I do 0 times x, that's 0. And if I do 0 times negative 3, that is also 0. So basically, when we multiply by 0 like this, all of this stuff is just going to be gone. So the only thing we're left with is that y is equal to negative 12. And this is in standard form because notice that my y is on the right or left side of my equation and my constant negative 12 is on the right side of my equation. So this is my answer right here. More specifically, guys, this is a horizontal line. Just as a reminder, remember, well, I can't remember if we talked about this or not, but all horizontal lines always have a slope of 0. So we kind of knew that going in with the slope. But that is exactly what that line is right there. It's a horizontal line at negative 12. All right, let's look at 4.1. In this first question, we're going to find the domain and the range. So I just want you to remember that when we talk about the domain, that is the x values that this graph is using. So we want to look at how far out to the left does this graph go and how far out to the right does it go. And what I want you to think about is I know that it's pointing up, but even as it's pointing up, it's still coming out to the right and it's still coming out to the left as it points up. So it is eventually going to use all of these x values that you see here because it's going to continue to go to the left and it's going to continue to go to the right. So our domain on this is going to be all real numbers. And remember, we can write this one of two ways. We can do negative infinity to infinity, or we can do it with this fancy R looking guy. That just stands for all real numbers. Either one of those is correct. Just make sure if you're doing the interval notation with the infinity to negative infinity that you use parentheses on both of those. So then the range, that is the y values used. So that's these guys right here. Now, we can see that this graph is going to go up forever. So it is going to go up forever, which means it is going to go up here to positive infinity. But notice that it is not going to go down forever. Okay, it actually stops right here at this value -3. So when we do our interval notation here, the lowest or the bottom of our graph is at -3. Since there is an actual point here at the vertex of our parabola, the point where it curves, that is going to be a bracket. And then it is going to go up forever, so that is going to be our infinity with a parentheses, and that's the domain for this function. So the next question is to determine whether this function is, or graph is a function, or this relation is a function. Remember, the way we do this is through the vertical line test. The vertical line test says that you can draw a vertical line anywhere on your graph that you want, and it will only touch the parabola or the U-shaped here, the blue line, one time. Okay, so if you think about just kind of taking like a piece of paper and sweeping it across this graph, you should notice that it will only touch it one time. So this is a yes, this is a function. Typically when things are not functions, you'll see like boxes and circles and things like that for not functions. So the same question on this one, we want to find the domain and then the range. So again, remember domain is all of our x values. So I want you to think about again, as this line continues to go, he's going to go to the left forever. He's going to go to the right forever. So our domain here would be all real numbers. Again, if you don't want to write it like that, you can write it as -infinity to positive infinity. And then for the range, we're talking about up and down. So now again, notice that it's going to continue to go down forever. It's going to continue to go up forever. So again, the domain on, or excuse me, the range on this one is all real numbers. Or again, -infinity to positive infinity. And then again, the second question on this is this a function? Again, I should be able to do a straight vertical line across this entire graph, and it only touches my line here one time. So that consists of a function. So my answer for the second part here is just yes, this is a function. All right, so our next one we want to rewrite as a function of x. So what we're going to do here is this is code for solve for y. So that's what we want to do. We want to solve for y. That would be our first step. And then our second step would be to change y to f of x. Okay, that's all we need to do in order to rewrite something as a function of x. We just solve for the y value and then we rewrite it. So if I look at this equation, I'm going to bring it up over here so I have some more room. 5x plus 4y equals -2x minus 3y. It doesn't really matter where you put the y's or where you put the x's as long as my y's are all together. I'm going to go ahead and move my 3y so that they're all over here on the left side of my equation, and that's just more because I like the way it looks, and it keeps my y over on the left side, which is where we like to see it. So this is going to be 5x plus 7y is equal to -2x. So then we're going to subtract that 5x because we need to get him away from our y's. So those are gone. So 7y is now equal to -7x. And then the last thing we're going to do is divide by that 7 to get the y by itself. And we're going to say that y equals -x. And if you put a 1 in front of, that's okay. But remember, we typically don't like to put 1s in front of our variables. So putting y equal to -x is fine. And then again, we're going to take this y and we're going to switch it out with f of x. So f of x is equal to -x. That would be our answer right here. Okay, now for step 2, it says, okay, well, now that you figured that out, solve for f at -3. don't go back to the original problem. You're going to take this value right here and you're going to stick it into whatever you solved for y. So in this case, we're going to put it into that negative x. So if we do this and we say, okay, f at -3, that's equal to -3. Remember that this negative here, this very first one, came from our function itself, and then the second negative is because we're plugging in a -3. And then two negatives make that a positive, so this would be a +3. Okay, I mean, you can find the same answer if you go back to the original problem and plug the -3 into the x's and solve and do all that kind of good stuff, but it's a whole lot easier if you'll do it right into the answer that you got from step 1. Okay, so step 3 of this problem is talking about implied domain, and we're going to talk more about implied domain here in just a little bit. But basically, you have 2,3 questions that you want to ask with implied domain. The first question you want to ask yourself is there a square root? And it has to be a square root, not a cube root, not a fourth root, but specifically a square root. And then the second thing we want to ask ourselves is there a variable in the denominator? Okay, so these are the two things we need to know. And then our third one is just, is there both? Is there some kind of combination of these two? Which right now, I don't think you need to worry too much about, but those are the two things that we have to talk about when we talk about implied domain. So really what I really want you guys to remember for your test are these two. Is there a square root, and is there a variable in the denominator? So really quickly, let me talk about what you're supposed to do. So if there is a square root, if you answer yes here, then what you're going to do is you're going to set the underneath of the square root greater than or equal to 0. So whatever sits under your square root is going to be greater than or equal to 0, and we're going to solve that equation and find our domain. And then if there's a variable in the denominator, what you're going to do is you're going to set the denominator equal to 0 and solve. Okay, guys, for the second one, your answer is going to look something like this, with that union thing in the center, because basically what you're doing is whatever answer you get from here, that's what goes into here, and that's the value you cannot be. So basically it's like you're having a little hole in your graph. I have an example of this here in just a second, but I just want you to know that that's how your answers are going to look for if you have a variable in your denominator for that second question. If you answer no to both questions, then your domain is all real numbers, okay? So let's put a little note out here that says no to both. Your answer is all real numbers. And again, you can do that with your negative infinity to positive infinity, or you can do the fancy R. So if we go back to step 1 and we look at our answer, that's this guy right over here, remember? And we ask ourselves, is there a square root in that? We should be saying no, because it's just a negative x. And is there a variable in our denominator? Well, no, because we don't even have a denominator, so there's no fractions to look at. So we're answering no to both questions. That means that our answer here for step 3 is going to be all real numbers. Okay, so for number 14, we just want to evaluate our function. And what we're going to do is we're just going to take this x squared right here, and we are going to plug that directly into the x in our function right there. That's all we're going to have to do to solve this problem. And honestly, once we do that, we're actually done, because there's nothing we can do to simplify. So we would get the square root of x squared plus 4 plus 6, and we're done. We don't have any like terms we can add. I still can't add the 4 and the 6 because the 4 is inside of my square root and the 6 is on the outside of my square root. That's all I can do to simplify that problem. Is all I'm doing is taking that value x squared and plugging that into where my x is. And I know that seems like a really silly thing to do right now, but we're kind of preparing you for some lessons that we're going to get here pretty soon. All right, so question number 15, again, is asking us for that implied domain. So we are asking ourselves the two questions: is there a square root, and is there a variable in the denominator, or both? So hopefully you're telling me that there is a square root. So what we're going to do again is we're going to take just the underneath. Don't worry about this -2 out here for the domain. We're going to take that and we're going to set it greater than or equal to 0. So we're going to have x minus 2 is greater than or equal to 0. So we're going to add 2 to both sides to solve for x. So we're going to say that x is greater than or equal to 2. Now, remember that when I answer, we want to write it in interval notation. We talked about this at the very beginning of school. We're going to, if you need to, we're going to draw our number line and we're going to put our 2 here, and we're going to say, okay, if we want x to be greater than 2, that means we're going to go out to the right, so that's going out that direction. Because we said greater than or equal to, we're going to use a bracket at 2, so we're going to use that squared off parentheses that tells somebody that you can actually be the number 2. So our answer for our interval notation on our implied domain would be a bracket at 2 going out to positive infinity with a parentheses. Okay, so remember, when you're doing these answers, you got to make sure to do that interval notation. All right, so another implied domain question here. This time, we notice we have a number in our denominator. So what we're going to do again is we're just going to, a variable in our denominator. We're just going to take this guy and we're going to set it equal to 0. Basically, what's happening when you have a letter in the denominator is that there's a possibility that your bottom of your fraction can be 0. And remember, we can never have 0 on the bottom. So all we're trying to do is figure out what that number is, because basically what happens is that's a hole in our graph. So we're going to take this guy and we're going to say x plus 8 is equal to 0. So we're going to subtract 8 from both sides. We're going to say that x is equal to -8. Now, what you can think about on a number line is here's -8, right? And we can be anything to the left of -8. We could be anything to the right of -8. We just have this giant hole right here at 8. So what happens is that hole is what gives us our union, okay? Because we want to talk about everything to the left of 8. We want to talk about everything to the right of 8, but we got to leave 8 out. So what ends up happening is on the left-hand side, we're going out to negative infinity. We're stopping at 8, but remember, we can't, -8, dropping that negative. We can't actually be -8, so we're going to do a parentheses. On the other side, we're doing the exact same thing, but just the opposite. Here, we're starting at -8. Now, remember, I'm using a parentheses because I can't be the number -8. That's my hole. And I'm going out to positive infinity. And so this would end up being my domain. Like I said, whenever we have that variable in our denominator, our domain looks really weird and has that union in it. All right. So almost done, guys. We just have this one last section left. So here we just need to pick out our graph. So I'm going to, remember when we're picking out our graph, we're just basically going to ignore this 4/7. And so the common function for this guy, or the parent function, is x cubed. And then because this has a negative, we're going to flip the x cubed function. So remember, our x cubed function looks like the snake. It comes up to the right, goes down to the left. So all we're going to do is look for one of these graphs that is flipped around, and that happens to be this guy right here. He is our snake function. If you don't remember, this guy is your x squared. This guy is -1/x squared because he's flipped upside down, and this guy is our x function. If you haven't looked over those, make sure you look over those before you take your test so you can at least identify which graph is which. All right, so the second part here is we're going to find 2 points on our graph. And these can be any points other than the origin. Basically, this means you cannot pick 0. So remember, our function that we're working with is, oops, I can't see it because I crossed it out. Shouldn't have done that. Okay, negative 4/7 x cubed. So we have h of x equals negative 4/7 times x cubed. What I like to do, since I can't pick 0, and 0 is one of my favorite numbers to work with, I just like to do x equal to 1, x equal to negative 1. I find that those two numbers are typically the easiest things to plug in. So if we do h at 1, this is going to be negative 4/7 times 1 cubed. Well, 1 cubed is still 1, so negative 4/7 times 1, which would just be negative 4/7. So my first point would be 1 comma negative 4/7. If I want to graph this, if I have to graph it, then I'm going to convert negative 4/7 into a decimal. So I can bring my calculator out here and do 4 divided by 7, and I'm not going to do the negative. I know my answer is going to be negative, and press enter, and we get almost a little bit more than a half. So this is 1 comma negative 0.57. Okay, so that makes it a little easier if I actually have to graph it on my graph paper. So it's a little bit past a half, or right there at a half. So I would go to the right one and down about a half, which would be maybe about right there. Again, when you're graphing decimals by hand, it doesn't have to be perfect. And then this guy would be h at negative 1. So this would be negative 4/7 times negative 1 cubed. Well, negative 1 cubed, that's negative 1 times negative 1 times negative 1. So that's going to stay negative 1. And then negative 4/7 times negative 1 would be a positive 4/7. So this would be negative 1 and a positive 4/7, or negative 1 and a positive 0.57. And guys, I just realized I graphed that wrong. It was positive 1.5, and then it is negative 1. Oops, I still did it wrong. I can do this. Positive 1 and negative half, and then positive 1, or negative 1 and a positive half. So our graph is going to look something like that. I don't know if he's going to have you graph them on your test, but if he does, again, just if you get a fractional answer, just take it to your calculator, figure out what the decimal is, and graph that point. Just make sure you pay attention to your signs, unlike me, who was not paying very good attention to her signs. All right, so question number 18 is we want to figure out which of the 4 graphs look the most like this function. Just a really quick note, notice the top just has this x, so this is a line with a slope of -7. So one of the key things you need to understand, negative slope means it's going down, and it's sharp because it's such a large number, because it's going to go down 7 to the right 1. So kind of think about that when we're looking at stuff. The other thing we need to notice in the second one, that is an x squared. So that is a parabola. Okay, that's our U-shaped graph. Now, what we want to do first is make sure that all of our graph options are breaking at -2, which they are. So the first thing we can do is we can eliminate the last 2, because the second part of the function, this part, is not a parabola, right? It has to be that U-shaped graph. So we know it's either going to be the first one or the second one. Now, the way we're going to figure this out is the next thing we're going to look at is we're going to look at these guys. So on the straight line, that is where I should have my solid point, because I'm saying it has to be less than or equal to -2. So if I look at this one, notice that right here, this is my straight line. It's my really steep incline. I know I said it's going sharply down, but remember it is going down because when we talk about down, we always talk about going from the left to the right side of the screen. Okay, so notice that this is an open circle. Open circles mean just less than, and look at mine. Mine said less than or equal to. Look at this graph. That is a closed circle, so this is less than or equal to. So this is my graph that I want. So when you're doing these, I want you to make sure that you're paying attention to what the two graphs are, because look, we eliminated two of them automatically just by knowing that that second half of the graph was not a parabola, which is what ours was defined to be with that x squared. So now we got it down to just a 50% chance. Then the next thing we start looking at is, okay, these are exactly the same graph, so the only difference is whether that circle there is closed or open. And then we look here and say, wait, it's supposed to be closed because we said less than or equal to, which narrows down our graph to this one. Okay. All right, so question number 19, we want to evaluate this expression when x is equal to -6. Remember, what we need to do first is figure out where -6 lies in our if statements over here. So notice we have x is less than -4, so -6 is less than -4. So we're going to plug this guy into that part of the equation. So we're going to have 1/2 times -6 minus 7. So 1/2 times -6 is going to give us -3 minus 7. -3 minus 7 is going to give us -10. So here's our answer, -10. All right, step 2 is the same thing, just we're going to use -4 is going to be our answer here. Again, looking back up here, x is not less than -4. Remember that it has to be equal to there, so it's not less than it, but x is definitely greater than or equal to -4. So we're going to use the second part of the equation here, and we're going to say 3 times -4, remember, plus 8. So that's going to give us -12 plus 8, so that's going to give us -4, and there's our answer for the second one. Okay, and one more apparently. We got -3 here. So again, coming back up here, we're looking at this. Is -3 less than -4? And remember, the smaller the negative, the larger the number. Okay, so -3 is not less than 4. -3, however, is greater than -4. So again, for this next one, we're going to use that same part, 3x plus 8. So we're going to say 3 times -3 plus 8. So it's going to give us 9 plus 8, which would be -1. So there's our answer right there. Number 20, the exact same thing, except now we have 3 different regions to look at, starting again, looking at x equal to 0 and figuring out where that sits. So 0 is not less than or equal to 3. -3 is less than 0, which is less than 7. So this is where my 0 fits, right here on this one. So -0 squared plus 0. So that's going to be 0 plus 0, which is just going to give us 0. So that's our answer there. It's a lot of zeros on that one. All right, so now we're going to do our next one, which is x equal to 9. Again, just looking at it going, okay, well, 9 is definitely not less than 3. 9 is not between -3 and 7, but 9 is greater than 7. So we're going to plug the 9 into that last one there. So 4 times 9 plus 2. 4 times 9 is 36, plus 2 is 38. So there's our answer for that second step. And lastly, x is, let me do a different color here. Oops. X equal to -3. It's that very first one. -3 is less than or equal to -3, so we're going to plug it in right there. So we have 1/2 times -3, minus 7. So this will be -3/2 minus 7. Now, if I want to do this by hand, I need to place that 7/1. My common denominator is the only bottom I have, which happens to be the 2. So we're going to multiply this 7 top and bottom by 2. So -3/2 minus 14/2. Remember, once I have a common denominator, I just add those tops So negative 3 minus 14 is going to give me negative 17 over 2. And that's my answer right here, negative 17 over 2. Or you could put it in decimal form and done the same thing. If we had done it in decimals, this would be negative 1.5 minus 7, which would give us negative 8.5. So this could be my answer as well. Although it does look like in your instructions that it wants it as a fraction if it comes out fractional. I don't know that Mr. Dillman will truly care whether you put it in a fraction or a decimal as far as your test, but the instructions do say fractions. If you have any questions or if you'd like to see another problem worked, I know I worked through these pretty fast, just email me and let me know. I will be in my office today as soon as the college opens back up. Hope you guys do okay. Again, let me know if you have questions.